Okay, well, welcome to the first entity relationship design exercise. In this exercise, what I wanted to do was take a look at a fairly simple database and show how we can go from a set of requirements to an ER representation that captures all of those requirements and will allow us to ask queries, to build a database and then ask queries on that database later on. Okay. So the topic for this database, and the database itself is one that we're going to return to in subsequent lessons, subsequent exercises, is a favourite topic of mine, beer. So in this database, what we want to represent is information about beers, obviously, people who drink beers and what beers do they like, and also whereabouts do they drink those beers. So let's get started on trying to put together some entities for the system. Okay, so an obvious entity that we can talk about is beers. Now, entities, remember, are drawn in rectangles, and in this particular exercise I'll be drawing them in pink. And entities have a bunch of attributes associated with them which capture the properties of those entities. In the case of beer, the two attributes of interest are the name of the beer and the brewer, or the manufacturer. And I'll represent that by MANF. I'm using these names to be consistent with the schema that I use subsequently. Okay, so that gives us two attributes for the beer's entity. And looking back at the requirements, we made an assumption that all of the names in the system are going to be different. So in other words, there's not going to be two beers with the same name. If that's the case, and thinking back to what we said about primary keys earlier on, then it would make sense to indicate that name is a primary key for the beer's entity set by putting an underline. All right, what else have we got? Well, we've got people who drink beer, and we've got the places where they drink them. So let's take a look at bars, and we're also going to look at drinkers. Right. So, what information do we need to represent bars? Well, looking back at the requirements, we at least need to know what the bar's called. So, its name, Coogee Bay Hotel or Royal Albert Hotel or whatever. We need to know where it is in case we want to go there and drink the beers. And since bars are licensed premises, we probably somewhere want to record a license number. So that gives us three attributes that we can associate with the entity bar. All right, now as I said, name is unique, so there are no two bars with the same name. Slightly unrealistic assumption in Australia, where every town seems to have a commercial hotel, but we did say in the assumptions names are unique, so once again we can use name as a primary key for the bar's entity. Okay, turning our attention to drinkers. Well, once again, drinkers have a name, drinkers have an address, and drinkers have a phone number. And that will give us three attributes for the drinkers entity. And looking at the requirements, that's pretty much all that we need to model for drinkers. Name, address and phone number. And once again, we're going to make the slightly unrealistic assumption that there are no two drinkers with the same name, so we can make name as a primary key for the drinkers table. Okay, looking at the requirements, I think that pretty much covers all of the entities in the system. Now let's take a look at relationships. Okay, one relationship is between beers and drinkers, and that relationship is related to the fact that drinkers like particular beers. So we'll have a likes relationship. The fact that it's called likes doesn't mean beers like drinkers. We have to choose a name, and whenever you're dealing with relationships like this, there are two ways you can read it. You could either say beers are liked by drinkers or drinkers like beers. So we've decided to choose the wording of the relationship name that goes in that direction. So the relationship is between beers and drinkers. It's an N-to-M relationship because a beer could be liked by many drinkers, a very popular beer, for example, and we're not restricting drinkers to liking just one beer. A drinker can like many beers, so N-to-M relationship. Next relationship between drinkers and bars. So drinkers go to bars in order to drink beer. We're assuming people aren't drinking at home, so we need a relationship between drinkers and the bars that they go to. So let's have a relationship called goes to, and once again we're reading it, the relationship in that direction. Drinker goes to a bar. And similarly to this relationship, it's also an N-to-M relationship because a drinker can go to several different bars. One bar may not have a beer he likes, so he has to go to a different bar. And conversely, the original bar has a beer that the other bar doesn't have. So drinkers can go to many bars, and bars, if they're not about to go immediately bust, will have many drinkers that go to them. The final relationship, we're running out of possible relationships that we can have between the entities in the system, but the final relationship is between beers and bars. And that relationship is to do with the fact that a particular beer is sold at a particular bar, and a particular bar sells a particular set of beers. So we'll have the sold relationship. A beer is sold at a particular bar. Now, the other piece of information involved in the system here is the fact that the price of a beer, of a particular beer, can vary from bar to bar. So Carlton Draft may cost $2.50 at the Coogee Bay Hotel and may cost $5 at the Royal Albert Hotel. So there's an attribute floating around in the system and we have to decide where it goes. Well, it clearly can't go with beers because we just said Carlton Draft costs $2.50 at one bar and costs $5 at another bar. So we couldn't have multiple attributes for each bar, the price at each bar. If we were to have a price associated with a beer, potentially we could have something like a single recommended retail price. Similarly, we can't associate the price with a bar. If we tried to do that, then what we'd be effectively saying is that this bar sells every beer for exactly the same price. So there's one price associated with the bar. So the price is actually associated with the fact that a particular beer is sold at a particular bar for a particular price. And so the attribute for price ends up being attached to the sold relationship. So we've got an attribute attached to a relationship. All of the other attributes in the system were attached to entities. And that pretty much completes the model, a model that satisfies the requirements that were mentioned in the original spec. And this is the database model that we'll be using for subsequent exercises.